Good morning, students. Till now, we have studied general form of quadratic equation, roots of quadratic equation, methods of solving quadratic equation. We have seen two methods, factorization method and second one, formula method. Okay. Today also, we are going to learn some important topics. Now see, first one, nature of roots of a quadratic equation. Okay. Now, how to determine the nature of the roots of a quadratic equation. Before that, now see this expression b square minus 4ac. This expression is called discriminant. Okay? This is called discriminant and this is denoted by Greek letter delta. This is denoted by Greek letter delta. See here given discriminant b square minus 4ac is called discriminant of a quadratic equation and is denoted by Greek letter delta. Okay. This expression is called discriminant. Okay. And this is denoted by delta. Delta is the Greek letter. Okay. Now this discriminant, by using this discriminant, we are going to determine the nature of roots of a quadratic equation. Now see this three condition. If b square minus 4ac equal to 0, that means delta. If delta equal to 0, then roots of the quadratic equation are real and equal. Okay. This is the first condition. If discriminant is 0, then roots are real and equal. If discriminant is greater than 0, then roots are real and unequal. Okay. And if delta or discriminant is less than 0, then the roots of quadratic equation are not real. Okay, understood? Now see these activities. Value of discriminant are given below and you have to write the nature of the roots. See here 50 is given. That means 50 is greater than 0. Okay. Then nature of roots. If delta is greater than 0, then nature of the roots. See here second condition. Roots are real and unequal. So here write roots are real and unequal. Okay. Don't write outside the bracket. Okay. Second, minus 30, which is less than 0. That means this third condition C. Roots are not real. Roots are not real. Okay. Again write inside the bracket. Last one equal to 0. Value of discriminant is equal to 0. And therefore roots are real and equal. Roots are real and equal. Understood? Now see the next topic second. Let's learn to obtain a quadratic equation having given roots. Let alpha and beta be the roots of a quadratic equation in variable. Now see alpha and beta are roots of quadratic equation. Therefore we can write x equal to alpha or x equal to beta. And therefore x minus alpha equal to 0 or x minus beta equal to 0. And after taking product of these two, we get here required quadratic equation. Okay. Like this, when two roots are given, we can obtain quadratic equation from this formula. Okay. Two activities are given below based on this formula. First I will try to solve. See, write the quadratic equation if addition of two roots is 10. That means alpha plus beta equal to 10 is given and the product of two roots, that means alpha into beta equal to 9. Then the required quadratic equation is x square minus here see alpha plus beta, addition of two roots, that is 10, therefore 10x, plus third term is alpha into beta. Alpha into beta is given 9 equal to 0. Okay. This is the required quadratic equation. Now the second activity try to solve. Okay. Now see the practice set 2.5. Now before practice set 2.5, let's remember these 2-3 points. First, nature of roots of a quadratic equation depends on the value b square minus 4ac. This is called discriminant. Okay, and is denoted by Greek letter delta. Okay, nature of the roots of a quadratic equation depends on discriminant, and discriminant is denoted by Greek letter delta. And this three conditions just we have studied. If delta equal to 0, then roots are real and equal. If delta is greater than 0, then roots are real and unequal. If delta is less than 0, then roots of quadratic equation are not real. Okay, and this last one just we have seen, when two roots are given, then the required quadratic equation is x square minus in the bracket alpha plus beta into x plus alpha beta equal to 0. Okay, now next practice set 2.5. Let's start practice set 2.5. Question number 1, which is activity based. Fill in the gaps and complete. Okay, quadratic equation is given general form. Here see this expression. This is called discriminant. Okay, discriminant is given 5 here and below minus 5. By using this value of discriminant, we have to find the nature of, or we have to determine the nature of roots. Okay, just we have seen three conditions, which if delta is great, delta means what? B square minus 4ac, which is greater than 0, then roots are real and unequal. Okay, and if delta is less than 0, then roots are not real. Now see here 5, which is greater than 0. Delta equal to 5 is given and which is greater than 0. Therefore here write roots are real and unequal. See below minus 5. Delta is given minus 5. Minus 5 is less than 0. Therefore, roots are not real. Okay. Now the second activity. Sum of roots is given minus 7. That means alpha plus beta equal to minus 7 is given. And product of two roots. That means alpha into beta equal to 5 is given. Okay. And you have to obtain the quadratic equation. Okay. Here. Now to obtain the quadratic equation, just we have seen the formula x square minus alpha plus beta into x plus alpha into beta equal to 0. Okay. Now see x square minus alpha plus beta is given how much? See here minus 7. Minus 7 x plus alpha into beta is given 5 equal to 0. Therefore x square minus minus plus 7x plus 5 equal to 0. This is the answer. Okay. So right here x square plus 7x plus 5 equal to 0. Understood? Now see the second question. Now question number 2. Find the value of discriminant. See, to find the value of discriminant, first compare given quadratic equation with general form of quadratic equation. Okay. Therefore, we comparing x square plus 7x minus 1 equal to 0 with general form x square plus bx plus c equal to 0. After comparing, we get a equal to, see this is a 1, this is b and this is c. A equal to 1, b equal to 7 and c equal to minus 1. To find the value of discriminant, b square minus 4ac equal to b square, that means 7 square minus 4 into value of a is 1, value of c is minus 1, 7 square 49, minus into minus plus 4 ones are 4, 49 plus 4 53. Okay, understood? Now second example this try to solve similar method. Okay, understood how to find the discriminant, and this expression is called discriminant, b square minus 4ac, and here we have to substitute the value of abc. Understood? Now the question number 3. Question number 3. Determine the nature of the roots of the following quadratic equation. This is the first example. In this example, we have to determine the nature of the roots. To determine the nature, first we have to obtain the value of discriminant. Okay. Just we have seen in the second example how to find the value of discriminant. Discriminant means what? B square minus 4ac is called discriminant. Okay. To find the value of this discriminant, we need value of ABC. So first comparing x square minus 4x plus 4 equal to 0 with standard form x square plus bx plus c equal to 0. We get a equal to 1, b equal to minus 4 and c equal to 4. Okay. Now substitute this value of ABC in the discriminant. B square, that means minus 4 square, minus 4 into value of A is 1, value of C is 4. Okay. 4 square, sorry, minus 4 square, 16, minus 4 for the 16. 16 minus 16, 0. B square minus 4AC, therefore equal to 0. Now, this is the discriminant, value of discriminant. And now we have to determine the nature of the roots. Just we have studied the three conditions, okay? When delta is equal to 0, then roots are equal and real, okay? Therefore, here roots are equal and real, okay? Understood? Same way, you try to solve the second and third example. Okay, question number, now see the question number 4. See in question number 4, we have to obtain the quadratic equation from the given roots. Okay. First example, here 0 and 4 are the two roots. Now consider alpha equal to 0 and beta equal to 4. Okay. And to form the quadratic equation, what is the formula? X square minus alpha plus beta x plus alpha into beta equal to 0. See, to find this quadratic equation, we need alpha plus beta and alpha into beta. So right here alpha plus beta, that means 0 plus 4 equal to 4. Okay. And alpha into beta, that means 0 into 4 equal to 0. Okay. Now substitute the value in the quadratic equation. X square minus 4x plus 0 equal to 0. This is the required quadratic equation. Okay. Now the second example, alpha is given here 3. So this is second example, and beta minus 10. The required quadratic equation is, before that, first find alpha plus beta, that means 3 plus minus 10 equal to 3 minus 10 equal to minus 7. Okay, and alpha into beta, 3 into minus 10 equal to minus 30. And therefore, required quadratic equation is x square minus alpha plus beta x plus alpha into beta equal to 0. Therefore, x square minus alpha plus beta, how much? Minus 7. So, minus 7x minus 30 equal to 0. Okay. Therefore x square minus minus plus 7x minus 30 equal to 0. This is the required quadratic equation. Okay. Next, question number 5. Now see the last example of practice 2.5. The roots of each of the following quadratic equation are real and equal. See, this important condition is given. You have to find k. Okay. Now see the first example. 3y square plus ky plus 12 equal to 0. In this example, one condition is given important. Which one? Roots are real and equal. Okay. Before that, first we can compare this equation with general form. Comparing 3y square plus ky plus 12 equal to 0 with general form ay square plus by plus c equal to 0. We get, after comparing, we get a equal to 3, b equal to k, and c equal to 12. Okay. See, condition is given. Which condition? Roots are real and equal. If roots are equal, or if roots are real and equal, then discriminant is 0. Therefore, b square minus 4ac. This is called discriminant and this is 0. Why this is 0? Because this condition is given. Roots are real and equal. Roots real and equal, therefore discriminant is 0. Now substitute the value of ABC is A, B, C in the discriminant. B square means k square minus 4 into 3 into value of C is 12 equal to 0. Therefore, k square minus 4 3 is 12, 12 into 12, 144 equal to 0. Therefore, k square equal to 144. Okay. By taking square root of both sides, here we get k equal to plus minus 12. Okay. And therefore, value of k equal to plus 12 or k equal to minus 12. Understood? Now the second example, same method is there. You try to solve. Okay. And again solve the complete practice set 2.5.